lesson is on division properties of exponents. Through your activity that we did, we've already learned the first property of exponents. If you're dividing numbers with the same base, or powers, I'm sorry, if you're dividing powers with the same base, you can subtract the exponents, the numerator minus the denominator, and you will get your answer. So an example here, 3 to the 7th over 3 to the 3rd, that gives you 3 to the 7 minus 3, which is 3 to the 4th power. So that is one of your properties that you figured out through your activity. The other property is when you have an entire fraction raised to a power. Okay? If you have an entire fraction, that means you've got parentheses around your fraction, then that exponent has to go to both your top and your bottom. Okay, so the example here, I've got 4/5 raised to the 3rd power. That is 4 to the 3rd over 5 to the 3rd power. So those are the two additional properties, and hey, guess what? It's our last set of properties too. So now after today, you'll know all the properties. We're going to start reviewing tomorrow. You got a test on Thursday. Oh, man. It's not a very good Valentine's Day present. I apologize for that.
Yeah, that's okay. We love you too.
Okay. So, letter A. Simplify the following. We have a to the 6th over a to the 14th power. So, what we need to do, they have the same base, so we can subtract our exponents. So, Nico, what would it turn into?
1.
Well, we're step at a time. What am I going to do first?
A.
6 minus 14, which is what?
-8.
A to the -8. Okay, now, am I happy?
No.
Can I stay like this?
No.
We got a negative exponent, so we have to get rid of that. It's going to have to go to the denominator. So we get 1 over a to the 8. Okay, letter B. Letter B, we have two bases. We have C's and we have D's. Let's take care of our C's first. We have C to the -1 minus 5. I'm subtracting my exponents. Numerator exponent minus denominator exponent. Times D, and then I have numerator exponent 3 minus denominator exponent -4. All right? So then we get C to the, what is that? -6, thank you. Times D to the, what do we need to do with these double negatives?
7.
Yeah, change it. It would be D to the 7th. Dexter, can I leave it like this?
No.
Is your name Dexter?
No.
Dexter, can I leave it like this? Why not? Why don't you think so? What's your gut telling you? But why? What am I not happy with right now?
-6 is not happy.
The -6.
The -6 we're not happy about. So we need to move it to the bottom. Correct. We can't have a negative exponent. It's got to go to the bottom. So we have D to the 7th over C to the 6th.
That's all I wrote.
Nico, you like math too.
It's easy. For me.
To you.
Alright, the next thing we're going to do is we're actually going to practice dividing scientific notation. They're going to give us some really big numbers in this word problem, and we're going to turn them into scientific notation to solve it, okay? Don't clear yet. Okay, so now let's look at the next one here. In 2000, the total amount of paper and paperboard recycled in the United States was 37 million tons. Population of the United States at that time in 2000 was 281.4 million. On average, how much paper and paperboard did each person recycle? That should say on average how many tons. How many tons? So what we need to do, we're going to turn these numbers into scientific notation, but what do we need to do? Like what kind of calculation, what operation are we going to use to figure out this answer? Anybody know? If I have a whole bunch of tons of recycled paperboard that's been recycled in a year, okay, and I have 281 million people, How can I find out how much? So now I know how much 281.4 people recycle. How do I know what one person recycled?
Divide.
You divide, yes. So we need to take 37 million and turn it into a number. 37. How many zeros do I put after that?
6.
Okay. So if I'm going to turn that into scientific notation. How do I turn that into scientific notation? My decimal's here. I want it here. So how many places is that?
1, 2, 3, 4, 5,
7.
7.
So 3.7 times 10 to the 7. The other number is 281.4 billion. That means it's 281 million and then 0.4 of a million. What's 0.4 of a million? You guys know? 0.4 of a million? 400,000. So it's 281 and then 400,000. Let's turn this number into scientific notation. Where do I want my decimal? In between the 2 and the 8. 2.8 times 10 to the
8.
oh 2.814. Sorry, left over. 2.814 times 10 to the 8th power. All right, we're going to divide those two numbers. Does anybody have any idea on how we even start to divide these two scientific notation numbers?
No. No.
All right. What we do is we take the leading numbers. The leading numbers 3.7 and 2.814, and we divide those two numbers. So when you divide those in your calculator, 1.31 times 10. Now, what do you think that we do with these exponents? What do we do with those exponents? What's the operation we do? Subtraction. So we do 7 minus 8. What's 7 minus 8? So we get 1.31 times 10 to the negative 1 power. So that's how you divide scientific notation. You just divide the two numbers and get whatever the number is. And then you just subtract the exponents on the tens. We can have a negative exponent on scientific notation, by the way. That's okay. Any other time it's not. But in scientific notation, we do have negative exponents. All right, example 3. Now we're going to apply the property where we distribute the power to everything in the fraction. So in letter A, we have 4 over x squared all raised to the 3rd power. So what that means is we distribute that 3. So we end up with 4 to the 3rd over x squared to the 3rd. Okay? Now, 4 to the 3rd, we can find out in a calculator. What's 4 to the 3rd? 64? We get 64 on top. On the bottom, we have a power to a power. What operation do we do with those? Multiplication. So we get x to the 6. And that's all we can do with that problem. All right, the next one, we do the same thing. We're going to distribute the 3 to the x. Okay. On the top, we just have x cubed. We don't know what that is because we don't know what x is. So we just write x to the 3rd power over y to the what? 6. And then, of course, you know I can't leave them this easy the whole time, right? We have to do some that maybe aren't as easy. All right, example 4, letter A. All right, we have 3/5 to the negative 2nd power. I'm going to show you a shortcut here. Rather than distributing the property first, I'm going to have you get rid of the negative exponent first. Nope. If I flip 3/5, that will make my negative 2 a positive 2. So if I do 5 over 3, then this is actually a positive 2. And the reason that works, here's why. I'll show you why it works once, and then you can just use this every time. But why it works is if we distributed the negative 2 to both the top and the bottom, we would have 3 to the negative 2nd over 5 to the negative 2nd. But what would have to happen to each of those things? They'd have to do it anyway, right? Because we can't have a negative exponent on top, it has to go to the bottom. If we have a negative exponent on the bottom, it goes to the top. So the 3 is going to go downstairs while the 5 goes upstairs and becomes positive. So then you end up with 5 squared over 3 squared. Well, what's going to happen? Isn't that my very next step for this problem? Right? So if I just skip this whole part, I just flip it, and then I distribute my positive 2 to both things. Okay? So then I can simplify this. 5 squared is 25 over 3 squared, which is 9. So when you have a negative exponent like that, you can just flip it. Okay? Like letter B. Letter B, we have a negative exponent. We also have a negative fraction. When I flip it, does it make the fraction positive? No. Good answer. Good job. No, it doesn't. So I need to flip it. Now, here's what you do with the negative fraction inside of a parenthesis. Pick the numerator or the denominator to throw the negative with. Okay? I'm going to put it on the bottom. There's a reason. But you'll see. So what I'm going to do is I'm going to flip it. I'm going to have a y over 2x, but then I'm going to stick that negative with the 2x. Because it's still a negative fraction. It doesn't matter where you stick that negative. I'm just going to put it on the bottom. And then we have that raised to the 4th power. So then that 4th power is now positive. And I can distribute it to both the things in the top and both the things in the bottom. So I have y to the 4th. And notice I'm keeping parentheses on these. There's a reason. Because on the last problems, it didn't matter. But on this one, we have to have parentheses because we have, on the denominator, if you notice, that 4th power has to go to both the negative 2 and the x. So we have to, again, do a distribute of the power, just like we did last week with multiplication. So now we have one more thing to do. All right, y to the 4th is just going to be y to the 4th no matter what. On the bottom, though, this 4 has to go to the negative 2 and the x. So we have to do negative 2 to the 4th times x to the 4th power. So the 4 not only has to go to the top and the bottom, but it has to go to everything in the top and the bottom. Do you see what I'm saying? So you may have to distribute it to the top and the bottom, and then distribute it to each thing in the denominator and each thing in the numerator. Because you have to look at every number and every variable separately. Now, let's evaluate what is negative. The only thing we have left to do is do negative 2 to the 4th power. What is negative 2 to the 4th power? 16. So you get y to the 4th over 16x to the 4th. Okay, we're going to do one more example. 2a to the 7th times 3a squared over 6a cubed. How can I simplify the top? What can I do in the numerator right now? Do what? Add what? What do you want to add? Yeah. They have the same base, don't they? They both have a's, so can we make that a to the 7th? Or 9th, I'm sorry. A to the 9th. So we get a to the 9th, but then what do we do with the 2 and the 3? Huh? Multiply them together and we get 6. And the reason we can do that is they each have an exponent of 1. So when I told you when you have a number, two or more numbers that all have exponent of 1, you can just multiply those together. On the bottom, we have 6a to the cubed, or 6a to the 3rd power. And then what did I say happens when you have the same thing on the top as you do on the bottom? What happens to them? You can cancel them. So what am I left with? A to the 9 over a to the 6.
3.
They have the same base, so you can subtract them. Oh, did I say 6?
Yeah.
I meant 3. A to the 9 over a to the 3. I'm thinking ahead. So that gives you a to the 9 minus 3, which gives you a to the 6. Your homework is letter D.
Sweet.
One homework problem.
That's a lot.
So I think you can all do that. My hint to you on this. My hint. But don't flip. My hint on this one is don't do the shortcut. Okay? That's all I'm going to say. That is your homework problem. Thank you for listening.